So now we're going to be looking at signals, periodic signals x of t, that can be written as a linear combination of these harmonically related complex exponentials. Okay. Now, these complex exponentials are essentially sinusoid, right? So it's a little bit hard to believe that, by combining different sinusoids, you can construct, signals of various forms, okay? So we looked at this example last time where, we looked at the combination of these complex exponentials up to k that is plus or minus 3, okay? And we showed that, as you add, more and more terms, right? As you add more and more of these sinusoidal terms on top of each other, you can eventually construct signals that, deviates more and more from the sinusoidal form. And in fact, you can start to imagine that as you add more and more sinusoidal terms onto this, you could potentially construct, any signal that you like, okay? Right. So this is just an example to let you sort of visualize, how signals can be gradually formed by, superimposing, more and more sinusoids on top of each other. Now, in this particular example, right, we started out with x of t that is a superposition of these complex exponentials. But, in this particular example, we ended up having a superposition of these real sinusoids instead of these complex exponentials, right? These complex sinusoids, okay? Now, this actually occurs much more often, right? Especially when x of t is real, okay? So in general, you would want to write it as a linear combination of these complex exponentials. But if x of t is real, you can generally write it as, linear combinations or superpositions of these real sinusoids instead, okay? So this is sort of just a side note here, okay? So like I just mentioned, if x of t is real and that it possesses a Fourier representation, then you can actually show that there are general forms of the Fourier series representation where you can write x of t as just a superposition of these real sinusoids, right? Either cosine with a certain phase or a combination of sine and cosine.